All right, how you guys doing? Hey, it's Mr. MathWell here. Just wanted to talk to you a little bit about Chapter 5 and Chapter 6 here, okay, in Foundations of Math 30. Ignore the double title there. I'm not sure what that's there for. So I just wanted to go over this document with you. It's just a view of terms and connections, and there's some practice questions here as well that you could go through in your preparation for Chapter 5 and Chapter 6 as well. So take a look at the words here: sample space, mutually exclusive, permutation, combination, ratio, experimental, factorial notation, theoretical, fundamental counting principle. So those are all terms that we've talked about. You should go back and look at those terms and their definitions if you're unfamiliar with those. But basically in Chapter 5, we're talking a lot about probability. We're talking about how many different ways certain things could happen with one set or multiple events happening at the same time. And so we talked about probability of tossing coins, heads and tails, and so on. We also talked about grouping people. If you have 10 people, how many people could you line up at the door, 2 at a time, whatever. It's maybe a 10, choose 2, right? That would be the answer to that question. And so we talked about permutations versus combinations. Permutations is the P and PR. So that would be n number of objects, and you would pick or find the permutations for r at a time. That means that order matters. So if you recall, AB and BA are 2 different permutations. The difference with combinations is AB and BA is only 1 combination. Okay, it's just how many, a group. The order that they're listed doesn't matter. So that's NPR and NCR. So here's some questions that you could work through, or at least take a look at these kind of questions. This is what you'd be looking at on the test. All right. This particular chart right here, if you recall this, products of rolls of 2 dice. So you could have products, you could have sums, whatever, and you would fill in a chart where this is, the first dice right here, the numbers for the first dice, and second die, I guess. And 1 times 1 would be a 1 here. A 1 would go there. And 1 times 2 would be 2. 5 times 2 would be 10. That's why you have 10 there. And so on. So you could fill in a chart like this for sums or for products or differences or whatever. But that's a chart that you might use. This is called a tree diagram. Okay. And we call it a tree diagram in our classes. And of course, you have this would be representing the number of rolls or flips of a coin, I guess. So this would be the first flip over here. It could be heads or tails. After that, you could have another flip, and then after that, a third flip. And this would be a tree diagram, a way of outlining all of your sample spaces. So you could have heads, 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 right? So heads here, and heads here. Or you could have head, head, tail, and so on. So that's a tree diagram. You may remember how we did that. If you have probability, take the number of positive outcomes divided by the number of total outcomes gives you probability. And probability could be in a ratio, 2 numbers with a colon. It could be a fraction like this, could be a decimal, or it could be a percent for probability. And here's some questions if you want to practice through. Again, I'll just let you pause the video if you would like to do that, to look through some of these questions and work through some of these answers. So that's Chapter 5. And I'll just get out of that one now. This is Chapter 6, okay? So Chapter 6 is quite different than Chapter 5. We're not talking about probability, odds, and all that sort of stuff. We're talking about actual, functions, okay? So this is a little bit more of the pre-calculus kind of part of Foundations 30. And we're talking about linear functions, talking about quadratic functions in the shape of a parabola. What is an x-intercept, right? That's where the graph touches or crosses the x-axis. The domain would be all the x values. The range is all the y values. Slope, you can calculate the slope of a line by taking any 2 points, calculating the rise, so the number of units of rise divided by the number of units of run, and so on. Increasing is from left and right when the graph starts to go up, and decreasing from left to right is when it goes down. And a graph like this has a portion of the graph is decreasing, and then at x equals 2, it changes to increasing, so on. All right, so yeah, we're talking a lot about functions and graphs and different things like that. Y equals mx plus b is really important. That's slope-intercept form for a straight line. Quadratic equations are where the x has a squared on it, and it could be in this form as well as your regular old standard form, which is, you know, y equals ax squared plus bx plus c. Okay. Also, a straight line can also be in another form, not y equals mx plus b. Could be in a form like this as well, where you have x and y and the constant term all on one side of the equation. So that's another way to write an equation of a line. Okay, so y-intercepts, of course, where the graph touches the y-axis and so on. This graph has a maximum point and no minimum point, because those arrows mean the line goes down forever and ever. So it has a maximum, not a minimum. The range here would be y values less than or equal to 5. You see, that's 5 is the maximum point, so it's everything underneath that. The domain would be XER. X is an element of all real numbers. All of the x values would be part of the domain there. Okay, talk a little bit about symmetry and that sort of thing as well. Okay, so characteristics of these graphs. Well, this is a straight line graph. It goes down from left to right because the slope here, this negative 0.4 is negative, so it goes down from left to right. Because there's a squared here on what would be the x here, that's a quadratic. Because this number in the very front is negative, that means it opens downward, you might recall. And so on, this x equals 3 is a vertical line. X equals 3 is a vertical line. Y equals 3 would be a perfectly horizontal line. Okay, so that's a little bit of, that's from chapter 6. So again, just a really brief review of some important terms and some important concepts. I didn't go over everything, of course, but just a real quick video just to kind of get you, just to check to see if you're sort of ready for chapter 5 and chapter 6 in Foundations Math 30. See you later.